Hello and welcome to this presentation about Buzzy towards realistic DBMS benchmarking via tailored representative synthetic workloads. My name is Jörg Domaschka. What I'm going to present here is a joint vision that I have with my colleagues Mark Leznik, Daniel Seybold from Ulm University, and Simon Eismann, Johannes Grohmann, and Samuel Kounev from University of Würzburg. Even though the title of the talk has DBMS, large database systems in it, we will not focus in the following on the database aspects. Instead, we will focus on the workload synthesization. Looking into reasons for benchmarking, we can coarsely distinguish between two different types of benchmarks. The one is a vendor-centric approach, where you want to understand how your system would compare to other systems in the market. And for that purpose, you usually would use some standardized synthetic benchmark that fits the field of the product you're selling. The other approach is client-centric benchmarking, where you're not so much interested in how fast and how good other setups are, but you want to understand how your particular setup matches the workload that you're currently having or will have in the future. And here you only have basically two options. The first option would be to replay real-world traces. That is, you would collect a trace from your system, production system, I would replay that against the system under test, tweak the configuration of the system under test, and finally find a configuration that's better suited than the previous one. The problem with real-world traces is that they're hard to get. They have no variation in the data. It's always the same trace, and they have a limited length and a limited scope usually. So you probably will not find anomalies in these traces. Option two would be to fall back again to the standardized synthetic benchmarks. And in these cases, you would have to find one of the benchmarks that fits your workload. So you would need an understanding of a large amount of benchmarks available, and you would then have the techniques and the skills to map one of these benchmarks to your workload under the condition that you understand actually what your workload is. Buzzy aims to have a tailored approach to benchmarking, that is realizing option two without the hassle of knowing the benchmarks and understanding the workload, because that's under the hood and that's included. So the overall vision that we have here is that we collect traces from a production system. We cluster these traces according to several possible classes. I'll get into that later on. And then we're able to synthesize new traces for each of these classes, by that enhancing the amount of available data and available traces. In the final step, we could then recompose the synthetic traces and throw them against the system under load. We expect that this would allow us to realistically emulate production workload, but still be tailored to individual systems. In particular, would be able to not only replay collected workloads, but also run what-if scenarios by changing how the traces are composed. Furthermore, this would give us similar traces instead of replay-only traces. So we have traces that resemble our currently workload but are not identical, and by that we expect to get an increased stability of the results. So we not only optimize for a particular sequence of operations, but rather for a group or setting. Overall, Buzzy has 4 steps of processing, and we will briefly go into each of them in the following. The pre-processing step basically deals with collecting the traces, collecting additional metadata, do some pre-processing, that is cleaning the data, rearranging data, and clustering. That will be needed later on in order to have less noisy input to the synthesization process. Just to give you an example, here we have a trace that has from different users, indicated by the colors, and we have different types of operations indicated by the lightness of the color, and we could then cluster obviously by the users, red, blue, and green, but we would also be able to cluster that by the color tone saying dark cluster and light cluster. So the challenges for facing in that step to realize our vision are understanding what information needs to be in the trace format, what is required and what is sufficient, and what helps us best to achieve our results. And when we talk about database management systems, also to capture the system state. That is the results from benchmarking that you would get in database systems not only depend on the sequence of operations, but it usually also depends on what's currently stored in the database, how much data is there, how many tables, which indices have been defined. And the second research aspect would be which clustering strategy is helpful for our goal. As said, we can cluster by use of operation, by data items, and by many other options. In the synthesis step, we take the observed workload clusters that we get from the pre-processing phase and uh, feed them into the data generator. Um, During that phase, we would also be able to enhance the synthesized data with anomalies, just to compensate for anomalies that we do not see in the data. Again, in the example, you could here see that the synthetic workload clusters that are the result of this step have a similar pattern than the original data, but they're not the same. And in the blue line, you could also see that there is an anomaly included. Research-wise, I think the challenges are in the synthesis part, where we will fall back on some neural networks based approaches that work really, really well in other domains. Here, the challenges are to ensure the semantic validity of the synthetic trace, to find metrics on how to measure the degree of similarity between different traces, and also to get an understanding of how representative a synthetic trace is compared to the original workload. Anomaly-wise, it is currently unclear to us how you would specify anomalies that you want to have and how you would want to integrate these into the synthesis step. The result of the step is a synthetic workload cluster, and in the composition step, we would take these clusters and recompose them in many possible ways. This could be as simple as just doing some sort of as-is replay. That is, we take the same amount and the same distribution of the synthetic workload clusters as in the original traces, and just rerun or run them against the the system under test. But we could also change the distribution of users to see what would happen if we allow 80% more users of that that group running in our system. The result is a sequence of is a workload trace. That is, we combine here in the example, we combine the red and the blue one. In that step, we expect the least research challenges. Nevertheless, there's the open question how you would specify the composition part. And for benchmarking, the question would be, could we just fall back to existing replay benchmarks, or would we need a customized benchmark implementation that is able to deal with these synthetic traces? Now, the current status is that we immediately after submitting the vision paper, we started working on that topic. Particularly, we started looking for real-world traces. Currently, we're focusing on getting database traces from MongoDB systems, so far without a lot of success, but we continue working on that. We also started working on replaying existing traces that we have, and we are investigating different approaches to clustering into synthesis based on previous work that we're having. Future work further down the road is to even look into more approaches to synthesis, to work on the anomaly enhancements and the composition, and along the way to establish a validation methodology to ensure that we can show that what we're doing is useful and reasonable. In case you are owning a DBMS workload trace, please get in touch. Or if you're able to generate a workload trace from a DBMS system, please get also in touch. Or if you work on similar matters in different domains, also get in touch. We're happy to discuss and to work with you on that matter. Also, in case of any questions, I'm happy to get back to you and to talk to you soon during the live sessions. Thanks for watching. Bye bye.